All right, let's start these problems. Basically, we're going to find that when we're maximizing or minimizing something, we take the first derivative and set it equal to 0, right? So it says here the perimeter of a rectangle is 64. So here's my rectangle, a length and a width. If the perimeter is 64, 2L plus 2W equals 64, right? Perimeter. Now, let's say I want to solve for W. It doesn't matter either way because I need to do area, which is length times width, but I need to get one variable so I can solve for it. So 2W equals 64 minus 2 times the length, right? Divided by 2W equals 32 minus L. So if my area is length times width, I have length times width is 32 minus L. So the equation itself for area is 32L minus L squared. In order to maximize, I have to take the first derivative, which will be 32 minus 2L. At my critical points, the first derivative is 0, so I'm going to solve for it. I'm going to find that L equals 16. If L equals 16, W is 32 minus 16, W is 16. So it just happens to be that the rectangle maximizing the area is actually a square. Okay? All right, now here we have 80 feet of fencing, but one side we don't need a fence on, right? So here our perimeter is 2W plus L, and that will equal 80, won't it? So, again, our area, what is the largest area? So we want to maximize the area. Area equals length times width. Now length here is 80 minus 2W. So why don't I say the length, 80 minus 2W, times W is my area, 80W minus 2W squared. Excuse me, so let's take the first derivative. That will be 80 minus 4W. Set that equal to 0. Add 4W to each side. Divide by 4. Well, our width will be 20. And our length will be 40. So we'll have 20, 40, and 20. That makes sense because we have 80 feet of fencing. So what is our maximum area? It's 20 feet by 40 feet, or I just check my math in case I make a silly mistake, huh? 20 times 40, 800 square feet. Okay. Now this was a tough one, or at least a lot of math we had to work out. But here's what we have. Oops, I grabbed the wrong one. So the area of this block right here would be x times y, right? But y is actually this function here, which is x squared over 3 minus 50x plus 1,000. So our area, if we multiply through, I'm just trying to grab it here. So our area is x to the third over 3 minus 50x squared plus 1,000x. All right, well again, if I'm going to maximize the area, I need to take the first derivative, which a 3 comes down in front, take out that 3, x squared minus 100x plus 1,000. Well, we weren't going to be able to factor that, so I said we need to use the quadratic formula, which says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, keeping in mind our closed interval. So negative b, 100 plus or minus the square root of 100 squared minus 4 times a, which is 1, times C all over 2A, which is 2. So that's 100 plus or minus 10,000 minus 4,000 gives me 6,000 under the square root. So if I figure out both answers, we'll find that one of them is not inside our interval, but let's try it. I'll do the adding. 100 plus the square root of 6,000 divided by 2. Notice, one of my x's is 88.73. That's not in our closed interval. So let's take the 100 minus the square root of 6,000 divided by 2. Well, x equals 11.270. And that should be maximizing the area. One way to test it out is to take this area function and graph it. So if I came in and I'm graphing, I'm going to graph the area function for a second. It looks like this. X to the third divided by 3, right? Minus 50x squared plus 1000x. So when I graph that, I'm going to get something that looks like something unusual. So I'm going to fix my window. It's still thinking. Alright. Okay, when I graph this on my calculator, and I have a top value up here of 6,000 on the y, I get something that looks like this. So I want to see where this maximum value is. I'll just test it to confirm what I did. I'm going to use my maximum function on the calculator, and I'm going to find that this indeed is the x that gives me the maximum area. So that's what you'll have here, 11.270. Alright, here's the first 3 questions. I'm going to stop here and start on another video.